Hi everyone, this is Mr. Cure. In this video, we're going to be looking at net ionic equations. So what you have in front of you here is a classic reaction. This reaction involves two colorless liquids, and what's going on is once you combine these liquids, you have this beautiful yellow powder being produced. So we all know this as a precipitation reaction. This is a classic precipitation reaction that involves the following. It involves lead nitrate and potassium chloride. So what's going to happen is we're going to have a double displacement reaction. So what happens is the lead is going to be displacing the potassium over here, and we're going to end up with lead 2 chloride. Let me just bring this over. So lead 2 chloride. And we're also going to have potassium nitrate. And then you look at your solubility rules. What you're going to find is that the potassium nitrate is soluble, as are all nitrates. And then lead 2, when it's with a halide, is insoluble. It forms these solids. So this is what the yellow is over here. The yellow precipitate is lead 2 chloride. Now, what's going to happen is we're going to keep track of what's happening behind the scenes in this reaction. So these are all ionic compounds. We're going to be looking at all the ions that are in solution and what happens. So the first thing that we do is we have to balance the reaction. So here's the balanced chemical equation. And what we're going to do is I'm going to draw a little diagram of what's happening. So beforehand, what I have is I'm going to have lead ions, lead 2 ions, 2 nitrate ions. So I have 2 of them because NO3 2. Here, because of balancing, I have 2 potassium ions and 2 chlorine ions. Now guess what happens? When we combine these, we're going to have 2 potassium, 2 nitrate, 1 lead, and 2, oh, this should be chlorine over here. There's a little typo. Let me just pause for a second here and fix that for you. Okay, there we go. It's a little bit better. So let's see what happens. So at the end of the day, what happens is I'm going to have the the potassium nitrate. It's going to be in solution, so it's going to be aqueous. So the ions are floating around, but remember the lead 2 iodide is a solid, so it's going to precipitate to the bottom. So it's going to form this solid precipitate at the bottom. No ions. Remember, the ions are in the form of a crystal lattice, so they're not floating around as these free-floating ions are. So then what we do is we write something called the net ionic equation, remember. So you list all the ions that you have in solution. So here in the first test tube, we're going to have 1 lead 2 plus ion, 2 nitrate ions, so make sure you've got the 2 here. I include the charges. I also indicate that they're floating around. They're solid in solution by writing down aqueous. Here, I'm going to have 2 potassium and 2 chlorine ions. Remember the coefficient in front. So I write down 2 potassium ions, 2 chlorine ions, and they're both aqueous. What happens afterwards? Remember, I'm going to still have 2 potassium, 2 nitrate ions. They're floating around. They're still aqueous. They're in solution. However, the lead iodide is solid. So I put down S. I do not separate. Do keep it together. Remember, this is a solid compound. We only write down the ions as aqueous and separated like this. So this is called the total ionic equation. You're writing down all the ions that you have in solution. Now you'll notice that some of the ions are there before and afterwards. So I have some potassium ions before, some potassium ions after. They're not actually part of the reaction. I can cancel them out. Similarly, I've got the nitrate ions over here. They're also found before and after. They're actually not part of this reaction. So I can cancel those out. And look what happens. I'm going to have lead plus 2 chlorines ions is going to give me lead 2 chloride. It should be chlorine over here. So sorry about that again. So when I write it like this, that's called my net ionic equation. So the net ionic equation is like a summary of the reaction, what's actually reacting. So we've got the lead ions, the chlorine ions here, 2 of them, and they give you lead 2 chloride. Let me fix this over here. Now the ions that aren't reacting, they're there before and after. It's like they're just looking on and seeing what's happening. They're like spectators. We call these spectators. They do not participate in the reaction, so we do not include them in the net ionic equation. So this is again a summary of all the ions in solution or in the reaction. So let's look at some more examples. Here's another one. Here I've got calcium chloride. It's going to be reacting with sodium hydroxide. And what's going to happen is the calcium is going to displace the sodium. So you're going to end up with calcium hydroxide and sodium chloride. And we do a little bit of balancing, so we put the coefficients in front. Now, I'm going to show it again. You don't have to always do this. It's going to help you understand what's going on. This is a diagram of the ions that are in solution. Let me just get rid of these crossings here. Here we go. Get rid of those. So this is a summary of everything that's in solution. So before, I have calcium chloride. It's in solution, 1 calcium ion, 2 chlorine ions. Here, I'm going to have 2 sodium, 2 hydroxide ions in solution. And then afterwards, the calcium hydroxide, solubility rules, it's insoluble, so it's going to form a precipitate at the bottom, so I keep it together. Remember, it doesn't form ions in solution. It's insoluble. And finally, this 2 sodium and 2 chlorine ions. And then we write down the total ionic equation. We simply list all of the ions that are here. So I'm going to have here, again, 2 chlorine ions, 1 calcium ion. Here we're going to have 2 sodium ions, and then 2 hydroxide ions. And again, we separate the ions, or dissociating, so they are floating around the solution. And then afterwards, what's going to happen is we're going to have, again, the calcium hydroxide. It's solid, so keep it together. Do not separate it. And then the sodium ions and chlorine ions, well, sodium chloride is soluble, so both of these are in solution. You've got 2 of each. So that's my total ionic equation. It simply lists everything in the actual solution, the ions that are soluble. Then what we do is we cross out the ions that are there before. So we've got chlorine, that's soluble before and after, so is sodium. So those are my spectator ions. So spectator ions, we cross them out. They should exactly cancel. And you end up with this. Calcium, 1 calcium ion joins with 2 hydroxide to give you a calcium hydroxide solid. So again, this is like a summary of the reaction, what's happening behind the scenes in these solutions. Okay. All right, yet again, here we have another one. So what we have here, we got calcium hydroxide, but this time it's reacting with hydrochloric acid. So what's going to happen here is we're going to have the following. The calcium is going to be displacing the hydrogen. So you're going to have calcium chloride. And then we're going to have HOH. What the heck is HOH? We know what that is. It's water, so it's a liquid. Okay. And then the calcium chloride is going to be soluble, so write down aqueous. And we do a little bit of balancing here. So I'm going to put a 2 in front here, and it looks like we're all done. Now what we do is we're going to draw all the ions that are in solution. So let's look at these. So I'm going to start this time, I'm going to start with the total ionic equation. So I'm going to write down all the ions that we have. So I've got 1 calcium ion, 2 hydroxide ions. Remember, there's 2 of them. Make sure you include the charges here as well. Don't forget about that. And the aqueous after each one. You don't lose formatting marks. Here, this is going to be forming ions as well. I'm going to have 2 hydrogen ions and 2 chlorine ions. Finally, calcium chloride is also soluble. So you have 1 calcium ion, 2 chlorine ions. Now remember, water is not an ionic compound. It's a molecular compound. It has covalent bonds. So you just leave it as H2OL, liquid. So what we then do is we cancel out these spectator ions. So let's see what we have here. We've got chlorine ions before and after. We cancel those out. There we go. So total ionic equation. I also have calcium here. And at the beginning, so what do we have? Oops, sorry, I forgot to cancel it out here. So I'm going to have 2 hydroxides joining with 2 hydrogens to give me 2 waters. And this would be your net ionic equation. That's how easy it is. It's not too bad, right? Okay, I think I've got one more for you. How about this one? Here we've got magnesium carbonate and sulfuric acid. What happens here? Well, again, we've got the displacement reaction. We're going to end up with magnesium sulfate. Here we go. We check it out. It's aqueous. And we also end up with H2CO3. Oh, what is that? Carbonic acid. But wait a second. We know something about this. The second this forms, it immediately decomposes into water and carbon dioxide gas. Remember, it's one of the special reactions from the reactions unit. So when we look at this, here we go. Let's see what we have in solution. So at the beginning, we're going to have one magnesium, one carbonate ion in this test tube. Here I'm going to have two hydrogens, one sulfate. What's happening afterwards? Well, I'm going to have magnesium sulfate. It's aqueous, so it's soluble. So you have magnesium ion, a sulfate ion. What happens though? Water stays behind. It's a liquid. And the CO2 is a gas. It escapes. So when I'm looking at the total ionic equation, you simply list all of the ions. Here we go. One magnesium, one carbonate, two hydrogens of sulfate. Here I've got a magnesium, a sulfate, water, and CO2. These are not ions, so it's just this part that's ionic. Then we're going to cancel out the ions that are there before and after, the spectator ions. Let's see here, I've got a magnesium, magnesium, aqueous. You have to double check it's aqueous. Oh, look, I've got a sulfate and a sulfate. So what do we have? I've got two hydrogen ions joining with a carbonic acid to give me H2O and CO2. And let's write that out. And that is going to be my, oh, there we go, net ionic equation. So this is my net ionic equation against a summary of the ions in this particular reaction. Okay, and we've got one last one here. Here we've got calcium nitrate and potassium chloride. Now this time, we're going to do the same thing. Here we go. Displacements, we're going to have calcium chloride. It's soluble. And what else do we have? We've got potassium nitrate. You look this up under solubility rules. It's soluble. So wait a second. Everything is soluble. When everything is soluble, remember, no reaction occurs. In order for a double displacement reaction to occur, you need to have a liquid being formed, a covalent compound, a gas, or a solid. Here, we don't have any of those. Well, why did that happen? Let's look behind the scenes. So when you list all of the ions, the total ionic equation, you can have a calcium, two nitrates. Here in this container, you have two potassium ions, two chlorine ions. Finally, you're going to have a calcium ion, two chlorine ions, two potassium ions, and two nitrate ions. So this is my total ionic equation. I simply listed all of my ions that are in solution. They're all in solution. Let's look at these spectator ions. So I've got a calcium before and after. Nitrates, I've got, oh look, two nitrates. They're both there before and after. Potassium, I've got two potassium and two potassium ions here. Chlorine and two, wait a second. Everything cancel. Everything is a spectator ion. What does that mean? It means that no reaction occurs. All I did is I had two containers with ions that are aqueous, and I simply mixed them to form another container that has just a lot of ions all mixed together. There's actually no reaction there. So again, what we'd write down is NR. You'd have no precipitate, no gas, no water, therefore no reaction occurs. Just a bunch of ions that are still in solution. So that's about it. So practice some of these questions. What's going to happen, is you're going to have to write down the total ionic equation, the net ionic equation by canceling out any spectator ions, and then you summarize things at the end. This is an extra step. It's optional. Sometimes I might ask you to do this on an assessment, but usually I don't, and this is just to help you right now understand what's happening behind the scenes. So that's it for net ionic equations.